Look, I think we should start.
Okay.
Yeah.
You got 25 participants.
25, yeah. I think we should start.
Okay. All right. What we're going to start with is the scope of epidemiology. Yeah. The topic is the scope of epidemiology. The scope.
Okay.
The scope of epidemiology. Okay. Now let's define epidemiology. What is epidemiology? Epidemiology is a study of the distribution and determinants of disease in human populations. Epidemiology is the study of the distribution and determinants of disease in human populations. Since we are talking about scope, we have to expand what do you mean by study? What do you mean by distribution? What do you mean by determinants? And what do you mean by population? So let's start with scope. When we talk about scope, it means patterns of disease, causes of disease, and three, the goal and control and prevention of disease. In other words, the study, cause, and control and prevention. Epidemiology focuses on health problems in the population rather than individuals. When we talk about a physician or a prescriber like you, when you go and sit at the OPD and you start attending to patients, you are attending to individuals. But when we talk about epidemiology, we are talking about populations, groups of people. So when we talk about causation of disease, we're also talking about natural history of the disease. How does it start? What is the cause of the disease? The health status of the population and evaluation of intervention. When we talk about a study, we say we are going to study the population. We mean we study epidemics like what we have now. What we have now is pandemic. When we say epidemic, it's in a particular population. But when we say pandemic, it means it affects the whole world population. Well, some people have just joined. Let me admit them. Good. And then when we talk about epidemics, like if you come to Ghana, for instance, you always have epidemics of cerebrospinal meningitis in the north. And right now we are having cases, and we're told 35 people have lost their lives. So that's it. We are talking about epidemics. We are talking about surveillance. And when we say surveillance, we are talking about surveillance of disease we have controlled, like measles, polio, guinea worm. And then observation, like hospital records. You go to the OPD, and then in a day, you like to find out how many cases of malaria we had, how many cases of measles we had, how many cases of polio we had, even though we've eliminated some of them. We also test hypotheses. We will come to that in detail. When we are saying hypothesis, you can say that people are getting diarrhea, and my hypothesis is that they are getting it from the water source, the water drinking source, and that can be a hypothesis. For instance, we test that and try to prove or disapprove.
Like I'm trying to order a market.
There's also analytic research and experiments, like giving malaria prophylaxis to pregnant women, for instance, and then following out to see how many of them develop malaria. That is experimental. Then when we come to distribution, so if we've dealt with the first one, which is study, we are coming to distribution. We said that epidemiology is the study of the distribution and the determinants of disease in human population. So we are now going to distribution when we talk about epidemiology. In distribution, we analyze the time of the disease. Like we all know we get malaria during the rainy season, it becomes worse. That's analysis of times. And then there's cerebrospinal meningitis during the dry season in the north. And then guinea worm during the dry season, where water becomes very scarce. That's where guinea worm becomes worse. So that is analysis of times. Then we talk about persons. Persons. For instance, if we talk about say schistosomiasis, that is people urinating blood. Which group of people are affected? And it affects mainly children, isn't it? When we talk about cancer of breast, it affects women. When we talk about prostate cancer, it affects men. That's what we mean by persons. So the distribution, we are talking about analysis of the time, the person, and place. The next one is the place. And when we talk about place, we know that asbestos factories, people working there develop, when they grow, they develop a disease called asbestosis, and that kills them. And people who work in areas where they crash stones.
Have you done your work? Have you finished it? Where do you put the underline? Where's the other one line? The other line, where is it? I come to tell me that you are hungry. Where's the other line?
Hey, first mute your microphone, please.
Are you having a problem? You are all on the line?
Yes, Doc, ignore. You continue.
Okay. Yeah, we were talking about places, and I was saying that people who work in asbestos factories develop asbestosis, which later on develops into cancer and they die. Those who went in quarries where they crush stones, they develop silicosis. And then the next one is classes of people affected. So in the distribution, we've talked about times, analysis of times, 2, persons, 3, places. The last one is classes of people affected. We know that those who smoke heavily, most of them end up with cancer of the lungs. If you If you're a heavy smoker, you know, you are likely to get cancer of the lungs. If you drink heavily, you can get cirrhosis or you may get cancer of the liver. So the crisis of people also. So now we are going to, we've talked about study, we've talked about distribution, we are going to talk about determinants of a disease. And when we talk about determinants, we are talking about factors, factors that influence health. For instance, those who like a lot of fat or fatty meals end up with high cholesterol.
It's true, sir. Good afternoon, sir.
Good afternoon.
Very, very true.
Yes. They end up with
like myself. So now I'm taking Crestor.
Oh, you take it?
Yes.
You were eating a lot of fatty meals.
You know,
You
school.
see? Yeah.
Because of school too.
Yeah. I'm lecturing.
It's on Zoom.
Then let's talk about chemicals. We are talking about determinants. So we talk about factors that affect health. When we talk about chemicals, those who are on steroids for a long time sometimes develop diabetes. We all know that. And when you are on steroids, your immunity goes down and you can easily develop disease like tuberculosis and other things. Okay, let's talk about physical. We are still at the determinants. Those who do a lot of exercise are fit. Those who refuse to do exercise grow fat, ending up in diabetes and so forth. So we all know that physical activity is important. You don't have to wake up and sleep 24 hours. Now, let's talk about social. There's a phone. Sorry, I'm being interrupted a little by your same students, so don't worry. You know, hepatitis B has become a social disease. If you go about kissing girls by heart, you end up with hepatitis B. It's a social disease. So, and if you go about injecting yourself by heart, you can get hepatitis B easily. Another determinant of disease is culture. In some cultures, when a lady dies, they give the wife to the next brother to marry. Imagine the husband died of, say, HIV, and he's giving the HIV to the woman, and they give the woman to the next brother. What will happen? So that's cultural. Now let's talk about economic factors as determinants. We know that poor people, their children are malnourished. Another determinant is genetic. You know, disease like sickle cell is transmitted genetically. Another determinant though is behavior, human behavior. Those who go about easily with life, they end up with HIV. Go about having sex indiscriminately, you end up with HIV. Now we go to health-related states and events that affect that affect health. And these include diseases, causes of death, behaviors such as smoking, positive health status, reaction to preventive regimes, and so forth. Now let's talk about specified populations. They include those that we can identify, and these include occupational groups like say welders, we can conduct experiments on them and find out that those a lot of welders end up with CA of prostate. I've also said that those who work in quarries, they end up with silicosis and occupational hazards like asbestos, people work in asbestos factory. Application to prevention and control. The aim of public health is to promote, protect, and restore. The aim of public health is to promote, protect, and restore health. So what do you mean by applied epidemiology? Applied epidemiology involves tracking diseases and disease indicators in the population. Excuse me, you've submitted, but you're supposed to pay your school fees.
Yes, so we are going to pay the half income.
If you don't pay, you
I've realized you
have
take some
50%.
50%.
50%. You don't pay now.
40%.
50.
Yeah, 40%.
You should be able to pay 70. Okay, I'm letting you please. Go ahead, go ahead. Sorry for the interruption. So, when we talk about applied epidemiology, we are talking about tracking diseases and indicators in population, and also seeking to reduce risk factors and then improve health. That's applied epidemiology. With all this knowledge, we track diseases like we go to quarries, and then we know that they are prone to silicosis or certain. So we advise them to wear masks, a whole lot of things, how to prevent inhaling dust, improve their health. So that's applied epidemiology. We apply epidemiology to improve health. Okay, our next topic. So this is introduction to the scope of epidemiology. This is the scope, how wide it is. Now what we are going to treat next is tools of epidemiology. Tools. When we say a tool, we know cutlass is a tool for a farmer. So let me admit some people who have just joined. Good. We are now getting 26 people, but it's still not enough. Okay, so our second topic for today is tools of epidemiology. And when we talk about tools, what are the instruments and implements that we use in epidemiology? These include proportions, ratios, rates, prevalence, incidence, study designs, bias, confounding variables, effect modification, odd and risk ratios, statistical power, and confidence intervals. All these are tools that we use for epidemiology. Now let's talk about ratios. When we talk about ratio, is a number of, for instance, the ratio of say diarrhea, children getting diarrhea, is the number of deaths attributed to the diarrhea in a particular group of children divided by the number of new cases of that disease identified during the same period. In other words, we go to a classroom where there are school children. They have school meal. Their total class is say about 24 children. And then out of the 24, let's say 8 develop diarrhea. And out of the 8, 2 die. So the death ratio is 2/8. That's the death ratio. That's what we mean by ratio. Now, let's talk about rate. Rate is a measure of the frequency with which an event occurs in a defined population over a specified period of time. For instance, we can say that, I would like to use diarrhea. We had diarrhea cases, or 300 new cases of diarrhea, or 400 new cases of diarrhea per 200,000 population per year. So the risk is not like a ratio, which is percentage. They are expressed per year, so they are quite huge numbers. Now let's talk about incidence rate. There are 2 very popular rates that we use, incidence rate and prevalence rate. And this one everybody must understand. Now, on the numerator, we have number of cases of disease. Number of cases of disease as a numerator, and number of persons at risk for disease. Number of persons at risk for disease as denominator. Let me give an example. If in a place, say in a classroom, somebody brings a poisonous substance and say a gas, a very dangerous gas into the room, and then explodes. Let's say the total number of people in the room is say about 20. And then 10 people become unconscious. Then it means all the 20 people were at risk. But number of people who were affected were 10. So it's 10/20. And that is the incidence rate. New cases over number of people at risk. When we talk about prevalence rate, we have the numerator as total number with the disease divided by total population times 100 or whatever it is, 100,000 or 10,000. For instance, if in a village population of say we have 200 people in a village, and then out of the 200 you have say 6 people with tuberculosis. So the prevalence rate is total number of people who have the disease over the total population times 100. So we use prevalence for chronic diseases, and we use incidence rate for diseases that occur fast, like say diarrhea and so forth, cough, diarrhea. But diseases like say TB, HIV, AIDS, we use prevalence rate. So Again, talking about the tools of epidemiology, we have different types of epidemiology. We have descriptive epidemiology, 1. 2, observational analytic epidemiology. Let me admit more people. We now have about 28 people joining. There's still not enough. I was expecting at least 40 something.
Hmm? You're not to 40.
Pardon?
Or is the regular and the.
Yes.
Okay.
So I was expecting more people. We are behind. Hello?
Hi.
Hi.
You're all around?
Yes,
Yes,
we
sir.
are all around.
Yes, Doc, we are
Yes,
here.
sir.
Good. You are listening. Okay.
Yes,
Now,
we are.
there are different types of epidemiology. The first one we are going to describe is descriptive epidemiology. 1. Descriptive epidemiology. This type of epidemiology describes the distribution of disease by person, place, and time, and useful for hypothesis generation, but not generally for hypothesis testing. Let me explain what I mean by it's useful for hypothesis generation, but not generally for hypothesis testing. Okay, you go to a place, because you are talking about distribution in terms of person, place, and time. You go to a place and you are getting a lot of children with malaria. Okay, let's say you are getting a lot of malaria cases. So you want to, after studying the OPD statistics, you want to generate a hypothesis. So you can say that malaria occurs in children or in adults. That's the hypothesis. In this village, majority of the children get malaria, or in this village, majority of adults get malaria. Or you can say that in this village, most of the people who get malaria live along gutters. This is a hypothesis, and you want to test. So what you do is you go to the OPD, collect all those data on all those who have malaria, and then you are going to look, first of all, at the age. What age groups get malaria? You're also going to look for how many of them stay near gutters. So if you analyze, you find out that in that particular group, most of the people getting malaria are children. Then your hypothesis, you have proved your hypothesis. So it's useful for generating hypothesis. Okay. The next one is observational analytic epidemiology. And this one focuses on, yes. Yeah, how can I do for you? Sorry to interrupt. Pardon? To Oh, send it to first row.
Register.
Forward. No. Ask them again. Hello? You are
Let's
all
go.
around.
Yes, we are here. Let's go.
All right, good. I want to admit more people too. Oh. Okay. Good. Okay. The next group of epidemiology types is analytic epidemiology. Analytic. Analytic epidemiology. And when we talk of analytic epidemiology, we are talking about searching for causes and effects on why and how. And this falls into two categories, experimental and observational. Experimental, epidemiologic analytic studies, and observational. The experimental determines the exposure status for each individual, like clinical trials or community trials. And then the observational study is more common. And that one is for the outcome status of each study participant. So there are two types of observational studies. These are cohort and case control. So now let me go slow so you understand. This is a bit complicated. We are talking about analytical. We have first one, observational epidemiology. Now we have analytical epidemiology. And that analytical epidemiology, there are two, experimental and observational. The experimental one is for clinical trials. And when we talk about observational one, we are talking about cohort and case control. Oh, you get it right. Cohort and case control. Now, let's talk about cohort study. It's like the experimental study, but it will categorize people on the basis of the exposure and observe them to see if they develop health conditions we are studying. In other words, for cohort study, we take a group of people and then we take them on the basis of how they are exposed. and they observed them over a long time. For instance, there was one Framingham test in America. What they did was they took doctors. As soon as they qualified, then they roped them, and then they categorized them into non-smokers and smokers. And even the smokers, number of sticks you smoke a day, and so forth. And they followed them up for quite a number of years, about 60 years or so. Many of them died, others are still alive. And then with that type of experiment, they were able to see that with emphasis that heavy smoking causes cancer. So this is what we mean by cohort study. You take a group of people and you divide them or you observe them according to their health status and follow them up for some years. Well, it differs from experimental study in the sense that cohort study, we observe the exposure status rather than determine it. We just observe, we don't determine it. They are already smokers. We don't tell them you smoke 2 sticks, but we ask them how many sticks you are smoking. After following them for some time, you compare disease rate in the exposed group and the unexposed group. In other words, like I said, if you select young people who have just finished school, young physician assistants, and then you categorize them into non-smokers, light smokers, and heavy smokers. You have to define what you mean by light smokers. Maybe smoking about, say, 5 6 a day, and heavy smokers smoking about, say, 2 or 3 packets a day. And then you follow them over, say, 50 years. You yourself who started, you may die, but some people will continue. And after, say, 50 years, you go back and see how many of those who didn't smoke got, say, cancer of the lungs. Those who smoke lightly, about 10 sticks a day, how many of them got cancer after 50 years? And then those who smoke heavily, like three packets a day, how many of them got, say, cancer after, say, 50 years? So that is what we mean by cohort study. And length of time you want to follow up depends on the type of disease. It can be cancers, it can be cardiovascular diseases and chronic diseases. Then let's talk about case control. So we've talked about cohort and case control, and all these belong to observational studies. The case control is another type of observational study. It's more common than cohort study. And for that one, we enroll a group of people with a disease and a group without a disease. And then we compare their patterns of life. In other words, this one, you can go to the OPD and collect all the files of those with cancer of the liver. And then you collect similar people who do not have cancer of the liver. And then you try to find out their lifestyle from birth until they develop the disease. That's case control. So the key in a case control study is to identify an appropriate control or comparison group because it provides our measure of the expected amongst them. So, in summary, I'm going to summarize all that I've said today. I've said that the purpose of an epidemiological study is to quantify the relationship between an exposure and a health outcome. And the hallmark of an epidemiological study is the presence of at least two groups, one of which serve as a comparison group. In an experimental study, the investigator will determine the exposure for the study subjects. In observational study, the subjects determine their own exposure. In an observational cohort study, the subjects first are enrolled on the basis of their exposure and followed to document occurrence of disease. In other words, observational cohort study, you start with a group of people and you know some of them are exposed to a particular thing and then you follow them up. Like you can go to a hospital and take all these people working in the X-ray department as a group, and then take all those working at another department like physiotherapy as another group and follow them up. So you know that those working the X-ray are exposed to radioactive substance, and those working at physiotherapy are not exposed. Then you compare the rate at which they develop, say, cancer. Okay. The observational case study control, we enroll people who have the disease already. And we also select controls who do not have the disease. And then we compare their lifestyles while they were young or before they got the disease. I hope you all get it.
Yes, sir.
I want us to discuss the last item for today, and then we can call it off because we have a lot to do. These are all beginnings. We are talking about sources of data, sources of epidemiological data. Where do we get data from epidemiology? One, we get some from birth and death certificates. Birth and death certificates. Population census records. 2. Patient medical records. In other words, you go to hospital, you get patient medical records. 3. Disease registries. And when we talk about disease registries, we have, in some places, we say you can have, say, cancer register. The names, the addresses, occupation of all those who develop, say, cancer. Then we can also have insurance claim forms. We can also have billing records. Then we have public health department case reports. We can also have case reports. We can also have case reports. So let me end with epidemiological design. Epidemiological study design. So I told you we have experimental and observational. We want to carry out an epidemiological study. We have experimental and observational. I've also said that epidemiology is a study of disease in populations of humans and other animals, specifically how, when, and where they occur. What are the risk factors and protective factors? And types of epidemiological studies. Types of epidemiological studies include cross-sectional studies, case control, and cohort studies. I think I will end here before I confuse you more. So we'll end here. And now I'll like the class captains to contact me so I know the best time that we can meet. If we are behind time, so if you are free, I'll be happy to. We still have a lot to cover.
Okay.
So thank you all very much. Do you have any questions?
Yes, Doc. Are there any slides for us?
No.
Hey.
That's why I should listen.
Yeah. Dr. Sir.
Hello.
Sir. Yes, sir. Dr. Sir, for the types of epidemiology, you stated descriptive, analytic, but later on when you were saying you talked about cohort control, case control, cohort study, and under observational.
Yes, I brought them further. We have experimental and observational. You see,
experimental and analytic.
Yes, and experimental and analytic, they all go together.
Okay. Okay, then descriptive.
Right.
Okay. Analytic and experimental observational. Okay.
That's why I don't want to confuse you further.
Okay, sir.
Okay, sir.
Any more questions?
They know to solve the problem. Oh.
What?
They know the slide. It will solve the problem. Oh.
No, as for slides, people just choose the slides and that's all. When you ask any slide question, they can't answer. People are choose for slides, you know. I'll give you the second points. Any other questions? Okay, we can call it course. Please, thank you for coming, but the number wasn't encouraging. Only 22 participants.
We'll do better next time, Doc. We'll do better next time, Doc. The next time
because you know I combined both classes.
Yes.
And you are over 50 something. If only 26 people came.
I think because of the timing, majority are probably at work, and not everybody can have the time to.
So I want the teachers to give me a time that is suitable for. We will never get a time that is suitable for everyone. So,
yes,
but we want a time that most people can take part.
A marginal time. That's fine.
Also means if they collect your notes, you won't understand it.
Okay, so Doc, we'll decide and then we'll let you know the time that will be a marginal point for everybody, convenient enough so that we can have the numbers take part in the next time. And then we'll revert to you. Is that right, sir?
I just give you the points for you to read.
Tablet.
Some people now want to join.
Tablet.
But we are finished.
Yeah.
We just finished and two people want to join. It's still not enough.
Okay.
Okay, let's pray that this ban will be lifted quickly so that we can have proper lectures.
All right.
Okay. Have a nice day.
Thank you.
Thank you,
You too.
Bye.